Hello, and welcome to our lesson on understanding the key features of quadratic functions, or introduction to functions. So today's objective is that you will understand the key features of quadratic functions. So first question, what is a quadratic function? Well, very simply, a quadratic function is any function that contains an x squared. That also includes times when you have an x multiplied by an x, but it doesn't look like the x squared. When you graph it, it forms a parabola. This is a parabola shape on the right-hand side. A parabola has very specific features. First of all, it has an axis of symmetry. It runs vertically, straight down through the vertex, which is another feature. The vertex is this point right here where it turns. You'll notice at one point it starts out where it is decreasing, and then it turns and ends up increasing. Or it can go the other way. It can be increasing and turn and end up decreasing. The vertex is the point where it turns. It is a point. It has an x and a y value. The x value is also the axis of symmetry. It is a line at x equals whatever the x value of the vertex is. We have a y-intercept. At some point, it's going to intersect our y-axis. In this case here, it is at -4. And we can have x-intercepts. Sometimes we will, sometimes we won't. We can have 0, 1, or we can have 2 x-intercepts. You see this one has 2 x-intercepts. Finally, we have a maximum or minimum. You'll see that on this, down here at the bottom, you can see that there's a minimum value here. If this was going the other direction, it would have a maximum value. So it definitely has a maximum or a minimum. So in this case, it has a minimum value right there at -4. So what do quadratic equations look like? So there is standard form, something like f of x equals ax squared plus bx plus c. Usually it looks up like this. You could have a number before the x squared, sometimes you won't. The c value, whatever this value here is your y-intercept. You can find your axis of symmetry by doing -b divided by 2a. So in this case, -b would be -5 divided by 2 times, in this case, a is 1. So your axis of symmetry would be at x equals -2.5. The axis of symmetry also gives you the x value of the vertex. So that is the x value of our vertex, -2.5. You could also tell a will tell us, the a value here will tell us if it opens up or down. If it is positive, it opens up. If it is negative, it opens down. Okay, so you get a lot of information from just looking at the equation. So let's look at another format it might take. Another format, this is called the vertex format. A times x minus h squared plus k. It might look something like this when you actually see it. Your vertex is hk. In this case, your vertex would be 3, 4. The a value still tells you if the parabola opens up or down. In this case, it is going to open up. And the absolute value of a, so this case, this absolute value determines how wide the parabola is. The one I showed you before had a value of 1. If it is less than 1, the absolute value is less than 1, then it means it's going to be wider when it's less than 1. And it is narrower when it is greater than 1. Okay? And one final way that we see them is in a factored form, something like this. Or, like I said, that's sort of the generic. You're going to see something that looks like this. The factored form helps you find the x-intercepts. So that's the one thing we haven't talked about finding so far. The x-intercepts are simply the values of x that would make each of our factors 0. So if x plus 4 would equal 0, then x would have to be -4. And it works that way because we would need it to be 0, and the only way to multiply two numbers and get 0 is for one of them to be 0. So in this case, my x values would be -4 or 7. So those would be my x-intercepts. Okay? So finally, when we look at quadratic functions on tables, we have things we call the first difference and the second difference. So this table looks like table of values we use for linear functions. But you'll notice it does not have a constant rate of change. Remember, our linear values had a constant rate of change, is always the same here. I notice I increased by 3, then I increased by 5, then by 7, then by 9. You'll notice this first difference is an arithmetic sequence. It is changing by the same number, and I can tell that by checking out the second difference. Second difference is, second difference, this is what in blue. The difference between these is a 2, and then a 2, and then a 2. So the second difference is constant in a quadratic function. So that's one thing to notice, is that you're gonna see that first difference is always be an arithmetic sequence, 3, 5, 7, 9, and it has a common difference or a constant difference of 2. Okay, so go ahead and look at these on your own, try your classwork, and I will see you in class if you have any questions.